Hello, my name is Maria Colgan, and I'm very excited to be able to give you a technical deep dive into the Oracle Autonomous Database in this session. So what is an Oracle Autonomous Database? Well, it's a family of cloud services that was actually introduced in 2018, and it's often referred to by its three lead characteristics. It's self-driving because it automates all of the database and infrastructure management, monitoring, and tuning automatically for you. It's self-securing because it'll protect itself from both external attacks as well as any malicious internal users. And it's self-repairing because it's going to protect itself from all downtime, including planned maintenance operations when we need to patch that system. And the whole purpose of this family of cloud services is, of course, to help you spend less and reduce your overall risk and innovate more, freeing up your valuable resources in order to be able to get better insights out of your data and drive your business forward. So what exactly is inside it? And if I open the lid of an autonomous database, what I actually see is it's made up of three key components. It's complete infrastructure automation on our Exadata platform. After all, that is the best platform for the Oracle database because not only is it pre-configured for the Oracle database, but it's also been pre-optimized for the database. The database in question, of course, is Oracle Database 19c, our long-term support release of the Oracle database, and our first release to encompass so much of this automation that's needed for the autonomous database. And in conjunction with both of those is, of course, all of the automation and machine learning we've brought in to optimize and complete all of the tasks you would normally do inside the data center when it comes to provisioning and running enterprise systems. So that's everything, including things like backing up those systems, creating the standbys, patching them and maintaining them. Everything that you would normally do as part of those data center operations is fully automated and goes part and parcel with the autonomous database. Now, just in case I haven't made it clear thus far, I just want to highlight this one fact, that it's not an incremental improvement over, let's say, an 11G Oracle database or a 12.1 Oracle database. What I'm talking about here is a new era of database, one where we're going to eliminate the fundamental problems that have plagued enterprise databases for decades. So what we're looking to remove is all of the complexity around administrating enterprise or real-time database or data management systems. We want to make sure that we eliminate all exposure to security vulnerabilities and the downtime that's normally associated with patching or in the event of a failure. We also want to ensure that there are no bottlenecks and that the performance on these systems will scale as you increase the resources for those systems. And we want to be able to ensure that you do have that elasticity to change those systems as you need it. So scale only when you need it and get you out of having to have high cost static configurations. When it comes to getting hold of the autonomous database, you can either get it as part of our public cloud, whether that's on shared Exadata infrastructure or dedicated, or Cloud at Customer, where you'll get the Oracle Autonomous Database on Exadata infrastructure inside your own data center, but fully managed by Oracle as if it was in the public cloud, but safe in the knowledge that your data is never leaving your data center. All right, so now you know what it is, where you can get it. Let's focus on exactly how it works. And what you're going to see is that Oracle is actually deploying our autonomous database using a combination of our existing industry-leading features and functionality, our best practices, and that automation with a little bit of machine learning blended in just to make it all work. And I'll explain exactly how we're doing it for each step in the process. So let's start right at the very beginning. Let's talk about how we provision an autonomous database. So when you press the button and you ask Oracle for an autonomous database, underneath the covers, we're very quickly going to provision you Exadata infrastructure. And on top of that, we're going to deploy a RAC database. That configuration is going to give us three key advantages. It's going to provide us a high availability configuration because if one of the RAC nodes was to go down, your application and database remain open for business as they'll operate on the remaining RAC nodes in that cluster. A rack environment also allows us to seamlessly scale out the solution should you need additional resources, because we can simply add more rack nodes to the cluster. But really the reason we use this configuration is actually to allow us to do all of our patching and maintenance operations fully online. While your database remains open for business, we'll be able to take down each of the individual nodes, do all the patching and everything we need to while your application and database continues to run on the remaining nodes in the cluster. Once we're finished the patching operation, we can bring the node back into the cluster and continue in this fashion in a round robin style until all of the nodes in the cluster has been patched. So how does Oracle decide where to place your autonomous database in this rack cluster? After all, if I've got especially a transaction processing system, I might be quite sensitive to the delay in communication if I have to communicate across a large number of rack nodes. We are going to provision your database on as few rack nodes as possible in order to get all the resources you need, but to minimize that impact of the cross-node communication. And people often ask me, well, hang on, you allow me to create an autonomous database with just one CPU. How is that a rack database? We will open your database on a single node in that case if you've just got one OCPU, but it is a rack database. So we can move that database around the cluster while it remains open, and that way you get just the resources you've paid for, but we get the agility to be able to move you around as necessary. When it comes to configuring the autonomous database, you are going to be asked what type of autonomous database do you want? Do you want an autonomous JSON database? Do you want a data warehouse or transaction processing? And the reason we ask you that at the beginning is so that we can optimize automatically the database for your specific type of workload. And that means we're going to take care of everything from the init.or parameter settings, managing the memory, the data formats, the resource management plans, basically everything for you out of the box. Now, oftentimes for those who are experienced with Oracle database, that makes you a bit nervous. What exactly is Oracle up to and how much control do I have for that configuration? So let's take a look at exactly how we set up both of these systems. As I said, you're going to be asked what type of database do you want? Data warehouse or transaction processing. So let's look and see how these two are configured differently and explain why that's happening. So let's start with the data warehouse. Now, with the data warehouse, we're going to be running analytical style queries that are going to be rather complex in nature. They'll do large scans, large joins, and probably aggregation functions. And so that is the goal that Oracle has in mind when they're configuring an autonomous data warehouse. We want to optimize for those complex SQL statements. And the fastest way to access data when you are doing those analytical style queries, of course, is to have the data in a columnar format. That way, when a query comes in that needs to scan a large volume of data, but they're only interested in one or two attributes or column values for that data, by storing the data in a columnar format, we only access the columns we need for the query, and we can automatically skip or prune out all of the other columns that we don't need. We are also storing the data in a compressed format inside those columns, allowing us to scan and filter smaller volumes of data and only decompressing the data when we need to return it to the end user. In order to find the data more accurately when we are doing these large scans, we're also going to create data summaries. And the first place you'll see these is where we take advantage of our Exadata storage indexes that are automatically created as data is loaded into the Oracle database. And what those storage indexes allow us to do is record the minimum and maximum value for each of the columns in each of the extents or chunks of data out on disk. And so when we come in looking for a particular value, instead of scanning all of the extents we have on disk, we'll actually go to the storage index first, check whether the value we're looking for falls within the min-max range for each of the extents, and that will actually tell us which extents need to be read to answer this query and which can be skipped altogether. Again, greatly reducing the volume of data that we need to access. Why? Because the fastest I/O you can do is the I/O you don't do. Now, when it comes to configuring memory for the Autonomous Data Warehouse, we're fully aware that there isn't really enough DRAM in the world to be able to cache all of the active working set of data you may have in your warehouse, especially if it's a large enterprise warehouse. And so rather than optimizing the memory for caching, we're actually going to optimize it to ensure that we can speed up things like joins and aggregations. So that means inside in the Oracle database, a good chunk of that memory is going to go to the PGA where those type of operations occur. Now, we also need to be sure that the Oracle Optimizer has all of the information it needs as soon as the data arrives in the database, so we can always get an optimal execution plan. And so the best way to do that is actually to gather the statistics as part of all of the bulk load operations. So as data is being ingested into the Oracle Autonomous Data Warehouse, we'll be automatically gathering stats for that data, including the creation of histograms. It's all going to happen automatically for you. So great, now we get an idea of what an autonomous data warehouse is going to look like. Let's see how an autonomous transaction processing system differs from that. Well, first and foremost, the primary goal, or what we're optimizing for, is rather different. Rather than optimizing for complex SQL statements, we're now optimizing for response time. Because with transaction processing systems, there's normally a human waiting for data. So we want to make sure that we're optimizing for that response time, that they get their data as soon as possible. And with transaction processing, we're often only interested in one or two records we have stored in the database, but we want to see all of the information we have for those records. So we're going to store the data in a row format, so all of the information about an individual record or row is stored co-located together in the same database block. Now, the fastest way to find an individual row inside a table, of course, is via an index, where we'll be able to get the row ID. And so we'll automatically create indexes to help speed up your workload on automatic transaction processing databases. And I'll explain how we do those index creations in just a little bit. Now, when it comes to transaction processing, the working set, or the volume of data that I'm typically interested in, is actually quite small. And it is possible to create enough memory in order to be able to cache that data and avoid doing any IOs at all. And so that's exactly how we configure the memory for our autonomous transaction processing systems. Again, the optimizer is going to need up-to-date statistics as soon as the data arrives in that transaction processing system in order to get the right execution plans. And so Oracle will automatically gather statistics as part of all of your DML operations. Because it's unlikely that you're going to be doing bulk loads on transaction processing, you're much more likely to be introducing new data through insert statements, updates, deletes, or merge statements. And for all of those operations, Oracle is now gathering statistics on the fly as part of the DML so that we can always keep the optimizer up to date on what's going on. Now, as I said, most people begin to get a little bit nervous at this point when they realize that Oracle is taking care of setting all of the parameters to their optimal values based on your workload. In fact, some of the values may differ from the regular database defaults that you might be expecting. So you might be wondering, well, what can I change then? And there are a limited number of parameters that are available to change for you, because we understand that, different parts of the world, you're going to need different time zone information, different date formats potentially, or depending on your particular type of application, you might want a different optimizer mode. So let's talk a little bit now about how Oracle automatically creates indexes for our transaction processing systems. And this is probably one of the first places that you'll see machine learning in action as the user. And so what it is an expert system that's going to look at your workload just the way a performance engineer would. Look and see what type of queries you're running, look and see the volume of data that you're touching, and then come up with a set of indexes that we believe would help benefit that workload. Now, unlike previous index advisors where each SQL statement would be looked at independently, with automatic indexing, so as we come up with those candidate indexes, what we're actually doing is first looking at each of the SQL statements independently, and then looking at them holistically, reducing the volume of indexes that need to be created. Once we've identified those indexes, they're going to go through a multi-step verification process to see if they'll actually improve the performance of your workload. So step one, before any indexes are created, we'll just generate metadata for the indexes, and we'll actually ask the optimizer, if this index existed, would you use it? If the optimizer says, yes, that looks like a good index to me, the index moves on to step 2 of the verification. If, however, the optimizer says, given the workload I've seen on this system, I'm never going to use that index, then the algorithm's going to learn from its mistake. It won't propose that index again, and that index won't obviously move on to step 2 of the verification. For all of the indexes that do make it to step 2, we will actually build those indexes. Now, it will be built in the background, invisible to the application. So your application will continue to use the existing execution plans it's got. But we will build the index because we want to actually verify or test execute that that index will actually improve the performance of your queries. So once the indexes are built, we'll do exactly that. We'll run your queries with and without the index and compare the performance. So everything from elapsed time to buffer gets will be compared with and without the index. And at that point, we'll make a decision about whether or not that index should be published. So that decision, of course, is based on whether or not we saw any performance improvement and if that performance improvement was seen across the board. So if we have an index that was used and improved the performance, we'll automatically publish it so your application can automatically begin to take advantage of that new index. If an index proves not to be useful, so in other words, it didn't improve the performance of your application, again, we learn from that mistake. We won't recommend that index again, and the index won't be published. But what happens if the index improves most of my queries, but for a small subset of queries, the performance regresses? Well, this is probably the most likely scenario in the real world. And in that case, what Oracle's going to do is we'll create a SQL plan baseline for the SQL statements where we didn't see a performance improvement. And that baseline will prevent those SQL statements from using the new index, ensuring that they continue to use their existing execution plans. Once those baselines are in place, then and only then will the new index be published to the application and allow the queries that saw benefit to be able to use the index, while the other statements continue to use their original execution plans, and so we don't see a performance regression. Now, this whole process that I've just described is fully automatic and transparent to the end users and, of course, to the application until the indexes have been published. But we understand that anything that says it's fully automatic does make people feel a little nervous or uncomfortable, and so it's fully auditable. You can actually get us to generate a report for you, show us exactly what SQL statements were being monitored, what indexes were proposed, what performance benefit we got, and which indexes actually got published to your application. All of that is visible to you in these reports. The reports are kept online. So there is a history. You can go back and look at them just the way you would AWR reports. And of course, you have a package, DBMS Auto Index, available to you to manage this as well. So in case you wanted to drop indexes or enable or disable automatic indexing for an individual schema, you can do that all through that DBMS Auto Index package. Now, when it comes to connecting to the autonomous database and the resources you're going to get, all of that is going to be controlled through database services. And the autonomous database comes with 5 predefined database services that will control, as I said, priority, parallelism, and concurrency. So let's take a look at what they are. We'll start with transaction processing. There's 2 dedicated services for transaction processing, TP Urgent and TP. Now, TP Urgent has the highest priority, so any user connected to that service goes to the front of the line. And with that, they get a high level of concurrency because by default, there is no parallelism on that particular service. However, if the user supplies a hint, they can use parallelism when they are connected to TP urgent. TP has the second highest priority. Again, there's no parallelism by default, and if the user tries to use parallelism, it won't be allowed. So just bear that in mind. Big difference between TP urgent and TP. Again, you can have a high number of concurrent sessions because there's no parallelism being used. Let's move on now and talk about the 3 additional services you can get. These services are geared towards autonomous data warehouse and, of course, towards reporting or batch processing on a transaction processing system. There are 3 services here: high, medium, and low. And as their names imply, that's their priority. So anybody coming in on the high service has the highest priority. They also have the highest parallel degree. So they'll operate with a parallel degree that's equal to the number of OCPUs specified for that autonomous database. There is a limit on the number of concurrent queries you can run. You can run up to 3 concurrent queries before statement queuing will occur on the high service. Medium, on the other hand, slightly lower priority, also able to run parallelism by default. And that means all SQL statements, by the way. So all DML operations, as well as all queries, will be automatically parallelized on both high and on medium. But with medium, it is a lower parallel degree. Instead of it being based on OCPU, it's actually a hard-coded value of 4. You can run more concurrent queries on medium than you can on high, but again, there is a limit. Once you reach that limit, we'll automatically start queuing your statements until the ones that are executing have finished. Low, as the name implies, has the lowest priority. And again, it can't use parallel execution just like TP, but the number of concurrent sessions you can have is much, much higher. So now that you've got a clear picture of the 5 predefined database services, I want to move on and talk about some of the other key advantages we get from the autonomous database running in the cloud. And that is, of course, elasticity. So you can instantly scale an autonomous database, and you can change both the CPU and the storage, but independent of one another. So there's no constraints. There's no fixed t-shirt sizes when it comes to scaling these systems. You can grow it incrementally and independently. So CPU or storage, they don't have to grow together. That way you get exactly what you need in order to achieve the performance you want without having to pay for any unnecessary resources. And as I said, all of these scaling operations happen completely online. And I wanted to show you a quick demo of this in action, just so you could see it for yourselves. So what I'm running here is a swing bench workload, and I'm actually operating on JSON documents inside in the Oracle database. So we're looking at the 4th column there. That's our transactions per second. And what you'll see is now that I've ramped up 128 users, I'm getting actually quite a variation in the transactions per second. I'm getting anything from 13,000 all the way down to 7,000 transactions a second. So let's have a look at what's going on the database by bringing up our database activity monitor and seeing what's going on. Well, if I look there, I can see already that there's a massive amount of wait for CPU, that I'm basically completely CPU bound. And I'm not really surprised, since I am running 128 users on just 2 OCPUs. If you look here at my cloud console, so I'm going to scale that up from 2 to 8, and I could have enabled auto scaling, but I'm not going to do that now. We'll do that in just a second. But you'll see instantly scaling is in progress there, which is great. And if I head back over to my swing bench, you can see that the transactions per second are still going. There's no delay, there's no pause while the scaling happens. It's happening completely online. And already I'm starting to see my transactions per second stabilize as those additional CPU cores become available. Now, it's not instantaneous, because remember, we're allocating not only additional CPU, but additional sessions and memory to the system as I'm doing this scaling. So let's move on and talk about auto scaling. With auto scaling, what I'm asking Oracle to do is to scale itself based on my workload. In other words, I don't know when I'm going to be able to go in and manually scale the database because I don't know when my workload may require that. So with auto scaling, you can tell Oracle, I'm giving you the permission to scale my database up to 3x the base number of CPUs I'm giving you now when my workload demands it. That way I'm getting additional CPU power and additional I/O bandwidth when I need it, but I don't have to pay for it when I don't need it. So it's going to really help me for those CPU and I/O bound workloads. Now, with auto scaling, why it differs from what I just showed you manually is that I'm not going to get additional sessions or additional memory when I use auto scale. So I am only going to get additional CPU power and additional I/O throughput. If I want more memory or more concurrent sessions, then I need to do the manual scaling, either through the UI, as I just showed you, or through one of the APIs or the SDKs. So just bear that in mind. There is a difference between these, but what's great about auto scaling is I can set it and forget it. And even if my workload spikes, Oracle will allocate me those additional resources as I need them. So let's take a look at this in action. I wanted to do a side-by-side comparison here where I have two autonomous data warehouses, both with 4 CPUs. One is going to have auto scale, one is not. So if we look at the left-hand side of your screen there, you'll see I have ADW1. It's got 4 OCPUs allocated to it, but auto scaling has been disabled. Whereas on the right-hand side, ADW2, it has also 4 CPUs by default, but auto scaling has been enabled, which means it has the ability to use 3x that base CPU count, or in other words, up to 12 OCPUs. So now let's start a workload. And what I've actually done is I'm actually running 8 concurrent statements on both systems. Now you may be wondering why 8, but remember I have 4 OCPUs on both systems by default, which means I have 2 threads per OCPU or 8 concurrent sessions that can run and without anybody having to wait on that configuration. So I'm running all 8 queries on both sides. If I look at database activity, I see 8 sessions on CPU just as I would expect. And I see on the left-hand side 100% CPU utilization because all of the threads of all of my CPUs are busy. But if I look on the right-hand side, I'll notice there, even though I only have 4 OCPUs allocated by default, I'm only using 33% of my total CPU. Why? Because remember, auto scaling's enabled and I could have gone all the way to 12 CPUs. So let's increase the number of concurrent queries we're running. Let's go from 8 to 24. Let's do it fully in line. I'm just going to keep adding those queries in. And now if I look at the database activity, what I see on the left-hand side is that 8 sessions are on CPU, just as they were before, but 16 sessions are having to wait for CPU. Why? Because I just don't have any more physical resources. Where if I look on the right-hand side, I see all 24 sessions are on CPU. Why is that? Well, Oracle scaled me from 4 to 12 OCPUs automatically as soon as the additional workload showed up. And because each CPU has 2 threads, all 24 queries can be running concurrently. And now if I look at the CPU utilization, I see I'm 100% CPU utilized on both databases, but on the database with no auto scaling, 16 sessions are waiting, whereas on the database with auto scaling, everybody's been able to run simultaneously. So really awesome feature because I'm only going to pay for those additional resources when I use them. And you can actually monitor this yourself. Through the console, we have these performance monitoring screens. So you'll see exactly how many OCPUs have been allocated at what point during the course of the day or the week or the hour. And you'll only pay for those additional resources when you use them. Now, one of the most popular features for the Oracle Autonomous Database, of course, is cloning, the ability to create a point-in-time copy of your autonomous database. And you can actually do it from any live running autonomous database or from a backup of an autonomous database. So if I wanted to create some dev or test environments using last night's backup or even last week's backup, remember, Oracle's going to automatically keep all those backups online for you. I can simply create a clone of that and instantly have a new autonomous database from that point in time. Now, there are two types of clones that you can create. You can create the clone as a full database clone. In other words, all of the schema, all of the data automatically copied over there for me in that new clone. Or it can be a metadata only clone. That means I'm just getting the schema definitions, but none of the data for that clone. Now, oftentimes people will ask me, how quickly are these clones created? And that really will depend on the type of clone you do. So metadata clones pretty much instantaneous. If I'm doing a full database clone, then the length of time it takes to create that clone will depend on the size of the data. The bigger the database, the longer it's going to take to do that full copy. But either way, it's super easy to do. You just select the database of the backup that you want to clone. You give us the details on where you want that clone to be in your particular cloud tenancy, a new name for it, and how much CPU and storage, because it doesn't need to be identical to the production environment that you happen to be cloning. Of course, I need enough storage to hold all the data, but other than that, I could use a lot less CPUs. And if I'm doing a metadata only clone, I don't even need the same amount of storage. I can do a much smaller footprint if I wish. Now, when it comes to securing your autonomous database, Oracle's going to have your back. We're going to automatically take care of securing that database for you. And just like all cloud providers, we're going to encrypt the data at rest. So it's automatically configured. You can't disable it or change this. All of the data that's loaded into the autonomous database is automatically encrypted. And so are all of the database backups. But Oracle takes it one step further than all the other cloud vendors by also encrypting all of the network traffic to and from the autonomous database. And you can choose two different ways to do this encryption. You can use Oracle's native network encryption, or you can go with the default, which is TLS, or Transport Layer Security encryption for those connections. And so when you're actually connecting to an autonomous database, you'll download a client wallet that will have all the encryption key information that you need to establish that secure connection. All autonomous databases leverage unified auditing. It's always enabled so that we are keeping track of everybody who's connected to your system, what's going on with the user accounts, with grants and privileges and roles. We're also keeping track of what's happening with the database structures, what tables and procedures and indexes and all of that are being created. And that log is available to you to check what's going on via our unified audit log trail views inside of the Oracle database. And you can even augment what's being recorded by taking advantage of the DBMS FGA package inside in the database in order to add additional policies. Now, when people hear that this is going on, they often ask me, is auditing on because your database operations folks are actually on my database? And the answer to that is no. It's actually on for your own protection from your own people. Oracle's operations typically don't go on your database at all. All of the patching and the maintenance activity that we would typically do is actually done fully automated. It's not actually done by humans, so there is no need for them to be on your database. But if for some reason you've run into a problem and our engineers do have to get on the database, unified auditing gives you that extra layer of comfort to know that you can see exactly what they were up to while they were there. So when it comes to really protecting or securing your system, we need to make sure there are no security vulnerabilities on that system. So we need to make sure that it's always patched up to the latest and greatest version of all of the software, not just the database, but the firmware, the operating system, the hypervisor, the clusterware. All of it needs to be patched and maintained to ensure we're not exposing you to any known vulnerability. And Oracle takes care of automatically patching all of those components for you on a regular schedule, and we'll even do on-demand patching for very critical issues. And those patches, of course, are being applied in a rolling fashion, both across the database rack nodes so that the database can remain open for business, and also across the Exadata storage cells, again, so your applications and your databases can remain open for business. So all of this patching happens completely automatically. There is a schedule published as part of the UI or through the APIs that you can query when the next patching window is for your particular autonomous database. And by default on our shared infrastructure, you can't change that window. But if you go with our dedicated deployment or Cloud at Customer, then you can adjust the patching window within a time range. So which month in the quarter, which week in that month, which day of the week, and which time period you want the patching window to begin within that day. So a lot of control for our dedicated environment if that's what you want to use. Now, as I said, Oracle is doing everything we possibly can to secure the system for you. We're taking care of encrypting all of the data, both at rest and on the network. We're taking care of all the patching, not just for the database, but the operating system, the clusterware. We're also, of course, making sure when our administrators go onto your system that they can't actually see your data. Why? Because we're using database vaults to protect your data. There is an automatic security realm placed around all of the user schemas so that our administrators can't actually see your data. There is an element of security that's still going to be your responsibility. And that's what happens when somebody legitimately logs on from your organization or via your app to the database. So what do I mean by that? I mean, you get to control which users can connect to your system and what privileges they have. You'll also be in control of protecting whatever sensitive data is in your schemas from those users. So should I be using data masking or redaction to protect some of that data? And if you want to increase the auditing. But don't worry, Oracle's not expecting you to do it all on your own. We do make our Oracle Data Safe service available to you for free with the Autonomous Database. And what that is a unified database security control center that's going to allow you to have Oracle go out, look at your autonomous database and do a security assessment for you, let you know whether or not some of your users have too much privilege. In other words, they've been granted privileges they don't actually need for their day-to-day activities, and help you lock down those accounts. We can also help you activate additional activity auditing, as well as the discovery of sensitive data and the automatic masking of that data for you. And we want to do this in order to save you time and mitigate any potential security risks you may have on these systems without the need for you to hire specialized security experts. And as I said, it's completely free for all Oracle Cloud databases. Now, in order to keep you secure and to make sure that we're going to protect you from any potential downtime or threat, Oracle's going to automatically take a nightly RMAN backup for you. And we're going to keep those backup online for a minimum of 60 days. Now, additional backups are possible. So if you wanted to do a point-in-time backup yourself before you roll out a new module or a new application, you can do that either through the UI or through any of our APIs. And of course, because you're manually taking those backups, they can be stored out in your cloud storage and can be kept for longer than the 60 days if you wish. So if you want to do a recovery, so say something goes wrong and you realize, we've made a mistake in our environment, we really need to go back to a previous backup. Not only can you restore to a previous backup, but you can actually restore to any point in time, so that we'll use a combination of the backups and the online archive logs in order to be able to get you to that point in time. So all the way up to 60 days. Now, we also, of course, want to make sure that all autonomous databases are highly available and are protected from any kind of hardware failure, software crash, or even just maintenance software updates. And that's why, as I said before, all autonomous databases are rack databases. Now, for more mission-critical systems, we also offer an extreme availability where you can have the added protection of a autonomous data guard standby. So that way, if something were to happen and we had a site outage or there was a database corruption, you could automatically and seamlessly fail over to that standby. Now, it is a fully managed standby. You just simply say to us, yes, Oracle, I'd like a standby for this database. No, Oracle, I don't want a standby for this other one because it's just a test environment. And it's completely transparent to your application. Oracle takes care of replicating the data over to the standby automatically for you. And in the event of a failure, assuming there's zero data loss, we'll automatically fail you over to that standby. If for some reason we can't guarantee zero data loss, then we leave it to you, the user, to initiate that switchover. So we'll let you know via messaging that there isn't a zero data loss in this scenario. Would you like to initiate a switchover? If you say yes, then we'll automatically switch you over to the standby. If you say no, you want to wait for it to be resolved on the primary, then we can do that too. Now, initially when we introduced Autonomous Data Guard, it was in the same region as the primary database, but cross-region is now available on our dedicated and is coming very soon on our shared infrastructure, so that you'll be able to have a primary database in one cloud region and actually your standby in a completely different cloud region. Now, with that, I just want to sum up and remind you of some of the key benefits you're going to get with the autonomous database. So we want you to be able to spend less. We want you to reduce your admin costs. We want you to be able to reduce your runtime costs, allowing you to truly get all of the benefits that are promised from the cloud of pay per use, but without having to compromise on performance and reliability that you would get with the Exadata platform. Because remember, it is an Oracle database running on Exadata, the best platform for that database. And we also want to, of course, reduce your risk. We want to make sure that you're protected from all external attacks by making sure that you're not exposed to any security vulnerabilities. We've also given you a high availability architecture and the option for DR if you wish to make sure that you're always available. And it's a proven configuration of Oracle RAC with our standby, all running on our Exadata platform. It's a proven architecture that has been run by thousands of enterprises around the world for their mission critical systems. And of course, by freeing up your valuable resources, getting rid of those mundane maintenance tasks like backing up databases or provisioning new databases every time dev or test needs something, your talented folks, your DBAs, your data architects, all of these folks can be freed up to focus on new projects, improving your user experience, and spending less time on admin means you can say yes to more new projects and instantly be able to start those projects because you can instantly provision a self-tuned Oracle Autonomous Database. And don't take my word for it. Why don't you try it out for free? Because the Oracle Autonomous Database is a key part of our always free tier. And that's available even for folks who have existing cloud accounts, or if you're brand new to the Oracle Cloud, you can take advantage of the Oracle Autonomous Database. And one of the best ways to kind of get familiar with it is to take advantage of our vast array of labs that are available there. You see the link on the screen that'll step you through the entire process, everything from provisioning that free database to fully utilizing. So for more information, please visit oracle.com/autonomous. Thanks for joining me.